Welcome back to the second video in our development series of the intake for the 991 Porsche GT3 RS. In the first video we showed you the stock airbox. We also scanned the engine bay to start the process. In this video we're going to look at the process of the designs in full. We'll also show you the prototypes, some performance testing of the prototypes, and then the actual carbon final versions along with more performance data. So first things first, let's go upstairs, head to my office and look at the designs in CAD. This is the 3D scan data which is from the GT3 RS. All the scans have been stitched together. I've coloured them in different colours just for the different sections. So all the grey parts you can see is basically the sort of envelope in which the intake will sit in. The copper coloured section is the throttle body, which you can see quite clearly. And then that gold coloured section is the shelf, if you like. It's the area which the boot lid secures to. One other thing which we did scan was the rear bumper to give us an idea of the exact space which we had. So I'll bring up the rear bumper. With the rear bumper in place, you can now see the complete area we have to play with. Obviously we've got the two inlets on each side, this one here and that one there. So the intake needs to start from there, which is where the air is pulled in from, and then travel around and into that throttle body. So that's the scans which we've got to play with, and now I'll bring up the actual design of the intake. Here's the intake design inside the mesh assembly. I'll run you through the features. So we've got the duct on each side, which helps to direct the air from the side channels into the main section. So the main middle section of that intake houses two of our reverse mounted filters. And then obviously that collects into this silicon which is directly attached to the throttle body. We've kept the shape as organic as possible, and the angle into the throttle body is nice and smooth, as you can see from that silicon. If I just make a cross-section machine, what I'll do is I'll turn that middle section transparent so that you can see inside that section. Now you can see those two filters, which are obviously reverse mounted, so we've got that Venturi effect happening, and it's quite a unique design because it's the first time where we've used two Venturi housings merging into one. So you've got this sort of Y-shaped housing almost, which has two filters in it. So you've got those two cones in the back of the filters almost pointing each other, but you should be able to sort of envisage the flow collecting from both filters into that central section going into the silicon. We've maximized use of the available space, as you can see, so we've kind of restricted here with those modules, and then obviously the shelf section, which I'll bring up, and you've got the catch which the boot lid secures to. So we've had to make reliefs under that catch on that center section, and then finally the bumper. So I'll bring up the bumper again. You can see the silhouette of that rear bumper and how close the intake is to the bumper, but there's enough clearance around it obviously for a bit of tolerance and a bit of movement. So we've obviously maximized where we can. The ducts themselves start at the same cross-section area as the stock ones because they have to go into the stock ducts, but then they increase in size quite rapidly up to that opening for the filters, and then round to the silicon. So all in all, it's a nice smooth organic shape. We've got a nice transition from both circular openings of the inlet ducts to the filters and then to that silicon. So that's the overview of the intake for the GT3 RS done. I've gone as far as I can in the CAD process. Now what we need to do is 3D print the designs, test fit them, make sure everything fits nicely, and then also performance test the initial designs and make adjustments where we can. In front of me we have the initial 3D printed prototype system for the Porsche. We've got the filter which I've removed, and I'm just going to show you the stock filter from the stock Airbox. Now it looks like an aftermarket filter, but interestingly Porsche actually used BMC to produce the filters for the stock Airbox, which is why it looks like an aftermarket one. But this same high flow mesh material they're using is very similar to what we're using, so the filtration standards are the same as the OEM specifications. Now you can see obviously the panel filter size is not big. There are two used in the Airbox, but the filtration area in our cone filter is a lot bigger, because that's a cone. When that's unraveled, it's a lot larger than each of these single panel filters. So the intake itself, we've got our two housings which are now merged into one piece. So typically we'd have two separate housings which would then go to separate intake tubes to the car, but obviously with one throttle body we've merged both housings to one, and this connects to the throttle body with one very short silicon adapter. We've made this as large as we can to make use of the volume in the engine bay, and you can see inside that chamber there's a lot of space in there, which is very good for allowing the airflow to develop as it moves through the filter and into that throttle body area. The filter itself goes into the housing in a reverse mounted fashion, which is what we typically do with all our Eventuri systems. So rather than being in that orientation, it goes into the housing like so. I'll just put this in. So that's how it actually fits in the housing itself. So you've got the cone inverted on each side. Airflow moves into the face of the cone and then is able to smoothly move out into the housing area, which then goes back in. And if I just pull this out one more time, you can see this is our custom-made filter, which we use in all our Eventuri housings. And on the back of the filter is this machined cone. And that cone has a very specific shape, which was CFD optimized to allow the airflow, as it comes out of the filter, to then be pulled back to the center of that section as quickly as possible without having a huge wake of dead space. So that cone is specifically designed to improve the airflow as it moves out from that cone. I'll put that back in. Okay, so that's the main body of the intake, and they are fed with cold air from two ducts either side. So we've got the duct which sits against the face of the filter, and it seals against the face of the filter, and it's connected to the stock inlets. So the car has two inlets on each side, which is fed from the side, the rear arches, and there's a duct which then forces air in to two tubes which come around the sides of the car to the back, and these then connect to those. So they seal against the mouth of the filters and they provide both sides with cold air. Again, we've maximized the volume where we can on these, so you can see a nice smooth narrowing. So that's where it sits into the stock inlets. It then increases in size to the filter openings. So that's the prototype system. Now we'll look at how this fits in the car, and the good thing is we can actually use this for some performance testing. So let's look at the prototype system in the car and on the dyno. With the prototypes tested, we refined the design to come to our final solution. And in front of me now we have the Porsche 991 GT3 RS full carbon fiber intake. As you can see, we've made some changes along the way. The most notable is how the ducts now are secured to the main body. Previously we had a rubber seal system which allowed some float and movement, but now we've bolted them together to ensure that there are no gaps at all. We've also changed the angle of the central body slightly to make that recess for the bonnet catch a bit less pronounced. The system is full carbon fiber and pre-preg, so no fiberglass used, and we'll show you that when I take this apart. And the final piece is the silicon coupler, and that just connects the carbon fiber intake to the throttle body. And it's a nice short piece, but it has a very nice internal profile with the steps, as you can see, to mate up against the face of that throttle body, which keeps the whole inlet track smooth as possible with no exposed edges. Okay, I'm now going to take this apart and show you the difference between this and the stock airbox. In front of me, the stock airbox. I'm just going to briefly go through how the stock airbox works. I did do a detailed rundown on this in the last video, so do go back and check that. But just as a brief overview, we've got the airbox which attaches on both sides to the stock ducts. So air is pulled in from both sides. It comes to the back of the airbox. The air has to then turn through the front, and you've got two panel filters on each side. So it goes through the panel filters into this front chamber. The air then has to turn around again and then converge out into this flexible tube section, which directly mounts onto the throttle body. If I just remove the front of the airbox, you can see that more clearly. So you've got airflow from the back of the filters, from the ducts. It comes out the filters, turns again into this collector. You can see that curve. So the airflow is coming into these chambers, both sides, and then moves out into this central area to the flexible tube to the throttle body. So the airflow is having to turn quite a few times. You've got a 90 degrees turn from the back, and then again from the front, and then back out. So you're doing a full, almost, well, what are we doing here? 180 almost, basically, which is going all the way around from the ducts to the throttle body. Let's now compare that to the Eventuri intake and see how that flows. In comparison to the stock system, the path that the air has to take is much more direct in this intake. So we've taken that apart, so you've got the two ducts with two filters already attached. And when they go into the housings, as we mentioned before, they are mounted in the reverse orientation. So now, airflow enters in the same position as the stock airbox, obviously, because you've got these parts connected to the ducts. But instead of the airflow having to turn up 90 degrees to go through the filter, the panel filter, and then turn again 90 degrees, and in effect do a full 180, airflow is moving straight into the filter without having to move 90 degrees, and is flowing out of the filter directly into the central section of the system, and then that collects and goes smoothly into the throttle body area with the silicon, obviously. So airflow is much more direct, which in effect means that the engine is working with less restriction because it's not having to pull air in from a very convoluted path. That translates to a better throttle response, and as you'll see when we do the tests, more performance because your flow path is less restricted. That, in conjunction with this chamber being much bigger in volume as compared to the stock airbox, gives you a larger area of air post-filter which the engine can use more readily. Again, that helps with the throttle response. So that's an overview of the carbon fiber intake and how the airflow is negotiating its way through from the ducts, the filters, to the central path. That's showing you, hopefully, an appreciation of what we do in terms of design with the airflow and the flow dynamics. Let's now see what it looks like in the car and finally how it performs. I've now fitted the carbon system to the car, and it's more apparent now how the airflow is actually much more linear, much more direct to the throttle body. So as you can see, you've got your airflow coming in from the side ducts, goes directly into our carbon ducts, and the filter, which is reverse mounted, sits inside the central housing area. So your airflow is coming through the duct and then going straight into that conical filter, moving through the conical filter and then straight into the central chamber and into the throttle body. Obviously, you've got convergence of both sides in the center. A lot more direct than the stock airbox. We've used lots of volume, as you can see. We've maximized on the volume whilst also keeping the airflow nice and smooth. Obviously, there's no point making this chamber huge, which will then have negative influence on the airflow because you'll have dead spots and turbulence to deal with. So it's nice and smooth in accordance with the lines of the airflow itself. With the intake finished and fitted, we now need to have a look at the performance data and see how it performs on the car. You saw earlier we've dyno tested the prototype plastic intake. We do that just to verify the design, make sure everything's working as we intend to. We then repeated the entire process in carbon, and that's done to double check the figures and obviously to make sure that the figures work as well, if not better, than we tested with the prototype intake. The tests were done on a hub dyno, and they were done on the same day, back to back, with the stock Airbox first and then the Eventuri intake afterwards. Hub dyno helps us also to minimize variables like strap tensions, which do play a role in normal dyno tests. The temperatures were the same, and now I've got the results in front of me, which we'll look at. Here's the dyno results. We've got all the information on the atmospheric data, temperatures, pressures and humidity. We've also got the headline peak figure, which is showing 7 horsepower. This isn't showing the full picture, so let's put this graph aside and have a look at the data in a bit more closer detail. The red line is the Eventuri intake in carbon, and the green line is the stock Airbox. We have highlighted where the biggest delta is, which is around 6,500 RPM, and you can see here it's about 11 horsepower and also around 11 foot-pounds of torque. And in fact, that delta is extended across quite a decent amount of that mid-range in the car. So you've got around 11, sort of 9 to 11 horsepower and foot-pounds of torque across quite a large portion of that usable RPM range. And at the higher RPMs, above 7,200, we've got around 9 horsepower. And the important thing here is the gains aren't just at a peak level. So it's not just at 200 or 300 RPM. You've got the gains above 5,000 RPM all the way across to 8,400, all the way to the peak RPM range, which is where you're going to be driving the majority of the time. So if you imagine on track, you're going to be shifting from redline down to 6,000 RPM, and you've got that usable RPM range with that usable power increase all the way across. So the car will feel more aggressive, a bit more responsive to drive, and the throttle response will be more apparent. So it's important to note that although the peak gain is just 8 to 9 horsepower, you've got that 11 to 9 horsepower gain across a huge majority of the usable RPM range, which is what counts. One of the other methods we use to verify the design is the flow bench. So what we do is actually we take the stock system and the prototype intake, or the actual final intake, to a flow bench, and at a given pressure drop we measure the actual flow rate achievable through the system. The flow bench is a very good way of verifying what the system is capable of, because it's a very controlled test. There are no ECUs involved or other sensors which may control or have influence on the performance and power of the car. It's literally just a flow bench and a set pressure drop through which the airbox or the intake is then pulled air from. In front of me I've got the graph of the results, and we've got the stock airbox showing a CFM of 905. Again, that's at a pressure drop of 28 inches of H2O. And the Eventuri intake has a measurable increase on top of that of 1025 CFM. So bearing in mind that the start and finish diameters of both the stock and the Eventuri are the same, so they're pulling in from the stock ducts and then ending at the throttle body, the fact that we've shown an increase shows that the path is smoother and there's less drag in the system overall, because we've increased the volumes through the middle section of that intake. So although it's not a huge increase in percentage-wise terms, it's still showing a measurable increase in the flow rate. So that's another validation on the design itself, and it gives us good confidence to move forward with the design. In summary, we did approach this project knowing full well that the RS model from Porsche is very well engineered to begin with, and that the stock airbox would also be very well engineered. We weren't expecting huge gains, but to be able to show and demonstrate a measurable gain across a large portion of the RPM is very good, and we're very pleased with that. The dyno results also back up the flow bench tests we showed you, which also showed a measurable and repeatable gain in flow over the stock airbox. The other thing to notice as well is that the fact that this is a normally aspirated car also lends itself to the fact that we weren't expecting huge gains from the outset. So again, showing what we have is very good. Normally when we approach an intake design, we have the advantage of improving upon a stock airbox which has to contend with NVH. So a production car, such as, for example, BMW or Audi, will use an airbox to attenuate the sound and to basically dampen all those NVH restrictions. And that gives us a lot of leeway to make big improvements in flow, and typically we see flow improvements of 30, 40, even 50%. With the Porsche system, we didn't have that advantage to deal with. So again, what we did show and what we did measure is a very good increase in performance. So in the end, we're pleased with what we found, and the owner of the car actually gave us some feedback after he took the car away and said that he noticeably felt an improvement in throttle response and how the car pulled all the way to the red line. And he's looking forward to taking that on track and seeing what it can do with the intake. Thank you for watching. I do hope that you found our development series on the Porsche 991 GT3 RS interesting. For technical details, there is a full write-up on our website, and for sales and availability, you can please contact your nearest Eventuri dealer.
Thank you so much for watching, guys. If you liked the video, please give us a thumbs up, and if you haven't already, please remember to subscribe to the channel and turn your notifications on. If you want to join the conversation, please drop us a comment below and we will do our best to respond to you. And if you're running out of things to watch, why don't you watch one of these two?